Thank you, everyone, for coming to this particular session. I do realize that there's quite a few other options that you could go to. So thank you very much for considering us worthy of your time today and spending your afternoon after lunch with us. So very grateful for that. I'm Barnum, and this is my colleague, Gopi. We are actually part of the Artificial Intelligence and Research org of Microsoft, and specifically we work on what we call the data science virtual machines in Azure. Today, with this particular session, we thought we'll give you a good sort of prime idea of what the product is, how we use it as a development platform and a deployment platform for AI and data science workloads. And we try to keep the session as general as possible, but also a little bit, focusing on a few deep dives later towards the second half of the session as well. We have a few new product announcements as well, which we want to cover, and we'll sort of go from there. So hopefully that is something that will be valuable to you guys. So first up, I'm a program manager in the data science virtual machine team, which is a part of, like I said, the Artificial Intelligence org of Microsoft. And today's session will focus on the agenda. Let me just go through the agenda. So initially, let me give you a good idea of what the data science virtual machines are in Azure. Where do they fit in? What are the capabilities, and why you should consider them as tools in your arsenal. Then we go into the new announcements of what we have, what we're launching at Ignite, and a few other things that are down the pipe. We'll then go into the actual workflow of using data science virtual machines in your development and AI org within your organizations. We'll give you a bit of an introduction into our new offering. I haven't specifically named it there because we do have a new offering. And then we'll do a couple of deep dives. Myself and Gopi will go into a few, give you an intro into the actual VMs itself, and what's included, how do you go and discover some of the capabilities, and then we'll go into the resources and next steps. And then we'll also be here for some Q&A after that as well. We'll keep it as interactive as possible. All right. First up, can I do a quick poll of the audience? How many of you are aware of data science virtual machines? Oh, wow, quite a few of you. It is a fairly new and up-and-coming service, so thank you very much for your interest. And how many of you have actually used them? Oh, quite a few of you. Cool. So as you may have seen, okay, I'm guessing quite a few of you went to the Scott Guthrie keynote. Did some of you go? Okay. And did you go to Joseph's session yesterday? The AI session? Okay, some of you. Cool. So in Azure, we obviously have the infrastructure layer, the platform layer, and then obviously the rest of Microsoft in Office and all. We also have the SaaS layer as well. So you must have heard a lot about the new platform offerings in machine learning and the new machine learning workbench, and the new capabilities within the machine learning services. In the infrastructure layer, where we want to provide the most comprehensive, least barrier of entry service for hardcore data scientists to come onto Azure and work, that's where data science virtual machines come into play. So what are data science virtual machines? Some of you already know, but let me quickly give you a recap. So basically, data science virtual machines are pre-configured environments for data scientists to use in Azure for AI modeling, development, and deployment. How did we come across building this product? Well, this is a product that was born out of need for Microsoft internally. We do have thousands of data scientists distributed across parts of the company and distributed across the globe. What we needed to do was to provide a consistent environment for all of them to work on, so that we do not have environment sprawl within our organization. And as a result of that, we polled them, and then we came up with a prioritized list of the most important languages data scientists care about, the development tools that they care about, the data ingestion tools that they care about and they need for data collection, the exploration and visualization tools that they need, what are the ML and AI frameworks they specifically care about. There are obviously a lot, as you may have seen. This is a space where there is a lot of innovation going on globally. And then finally, what are the data platforms that they care about? We do have the new offering of deep learning virtual machine that I'll go into, but these are the specific themes that we got out of our surveys and research, both internally and externally, and we combine them together in the right the most popular requested configurations, the most popular requested, let's say, installations and versions of packages, etc., which becomes quite difficult to manage. So we've done that at scale, and we've tested it across a lot of examples, and then and made that image internally for Microsoft, and then we externalized it about just a little bit under 2 years ago. So if I was to look at what editions are available for Data Science Virtual Machine today, so for those of you who are aware, we have the Data Science Virtual Machines are available in Windows Server 2016 versions, Ubuntu versions for Linux, and we also have, this is the new SKU that we're launching at Ignite, which is available in the Azure portal today, which is the deep learning virtual machines. Deep learning virtual machines are basically, underneath they are using the Data Science Virtual Machine image, but there's some specific configurations to be used for deep learning workloads and specific end-to-end samples that get put on the machine when you employ it through that particular SKU. And you can choose if you want to use Windows or Ubuntu for that matter. So let me go into the other announcements now. And I hope it's okay with you. Let me cover off all the slideware and the announcements first, and then we'll go into a little bit of the internals of the VM itself. So in terms of by the way, we also do have the CentOS and Windows Server 2012 versions. I haven't covered them here because they are our older editions, but they are also available if you're an organization that needs to use a Windows Server 2012 edition or a CentOS edition as well. All right. And yeah, feel free to take photos. In terms of the major announcements, the first major announcement that I spoke about is we're introducing a specific deep learning SKU. This is actually, we have been working with thousands of customers who use Data Science Virtual Machine, and we've realized that there is a specific need for very specialized machines for deep learning as an emerging workload, which specifically employs GPU hardware for AI training and stuff like that. And there was a need for us to develop this SKU because primarily deep learning is an area which does need specialized skill. Also, it needs specialized discoverability as well, because it's not just traditional data science. Deep learning is a field of its own. So we thought, we make it, because we use it internally, it makes sense for us to have it externally available as well. So this is our first major announcement. You can go to Azure portal today and deploy this in either Windows or Linux versions. We are also available in now, just before Ignite, we launched into the Azure government, US government clouds, and we're also available in Azure China as well. So these are two major announcements that we're making. We're actually already available in all Azure public regions. So it's one of the major data services in Azure that's available globally, and now also available in Azure government and also Azure China. We also, just to put it out there, we are also planning very imminent launches of other sovereign clouds like in Europe and et cetera as well. So if you are looking out for those, we are planning announcements very quickly in those regions as well. Next announcement, we actually have had Spark on our Linux data science virtual machine for a while. Let me give you a little bit of a precursor to it. So one of the requests that we've had previously, which is why we've done it before, is that developing on Spark is an expensive proposition for most organizations, including ourselves. A minimum Spark cluster with 4 nodes will cost you anywhere from $4,000 to $8,000 a month just to keep it running, and these are not temporarily available clusters. So one of the requests that we have was to enable cheap development for people who want to work with Spark clusters. So we enabled a on-VM Spark cluster in our Linux Ubuntu instances a few months ago, and now we're making it available on our Windows instances as well. So that's another major announcement. A lot of work has gone in to make sure that our samples and our examples work out of the box with it.
The Spark, that installation we have on the data science, it's a standalone instance, so it makes it very easy to also debug. So when you're debugging, if you have like a cluster across like multiple machines, multiple processes, so this is another way that we can speed up like development by offering this. So we had a lot of customers that ask us, okay, we like to use it on Windows. So this is kind of in response to some of those requests.
And another thing is like we've actually configured like specific kernels to point either to the local instance, and let's say you have a HT Insight cluster and you want to, once you're comfortable with your local runs with, let's say, 1% of the data and training a model or working with 1% of the data, now you want to externalize it, put it on a production cluster, then you just change the kernel over, let's say your Python kernel pointing to a HT Insight cluster, running Spark on top of it, then you can run it on the larger data set. So in a way, like instead of spending like $8,000 just to develop or hitting a fully utilized production cluster, you're working on like, let's say a $300 a month kind of cluster that you can open and close whenever you need, right? The next major announcement, actually this is not specifically to DSVM. Like I said before, there has been a lot of announcements at Ignite around our PaaS services and our client services for machine learning. So we one of the things that we were doing is with both the Windows and the Linux versions of Data Science Virtual Machine, we're making it super easy to get onboarded into Azure Machine Learning new services and also Azure Machine Learning Workbench as well. So both from the command line and the GUI interface, with the Windows version, we actually provide a one-click installer. You can go and just run the installer. It will actually provision the Azure Machine Learning Workbench on your VM itself. You can either then use it if you go and try out Azure Machine Learning Workbench, then you can either go and use the local Windows DSVM or Linux DSVM as the primary training component. And then let's say you want to publish it to a container space or run your trained models in a VM. It doesn't really matter. Basically, you can use GPU power. That's the whole idea. The next announcement that we're doing is this is an upcoming service that should be available very shortly from Microsoft. How many of you are aware of Azure Batch? Okay, very few people.
How many of you are aware that Data Science VM was available in Azure Batch?
Okay, one person. So Azure Batch is as simple as it sounds. Azure Batch is a batch compute service that is available in Azure, where you can run very highly parallelized batch jobs on schedules or ad hoc. So this is temporal resources that get spun up whenever you need them for however long you need the job to run. So it is. It also takes advantage of the lower pricing of lower priority virtual machines if you've actually configured your job that way, because these are not virtual machines which are hot all the time. So Azure Batch, if you haven't looked at it today and you do have scheduled running major jobs, I would suggest go actually have a look at it. It might actually solve a lot of problems that you might be solving in maybe not as efficient ways. So one of the things that we're working on with the Azure Batch team is that because deep learning inherently is a workload where you want to use parallelized GPU compute and stuff like that, especially when you're training things which are like highly cognitive in nature, large-scale image classification, parallelized conversational bots or something like that, and you're training, let's say, a cognitive toolkit or a CNTK or a TensorFlow model for some of those extremely high compute-intensive workloads, you want to utilize like thousands of GPUs, let's say, maybe for only 4 hours, right? So for that particular service that is being launched by Azure Batch is called the Batch AI Training Service. This is specifically for deep learning, and data science virtual machine will be the backend, one of the backends that will be powering the batch AI training service as well. So if you are interested, please go have a look. This is a service that's coming online very shortly. Right. One of the other things that we're doing as a part of the deep learning VM launch is that one of the attractions of DSVM, and for the 40% of the room that are aware of DSVM, is that we actually package about 45 to 50 specific end-to-end, fully pre-done, pre-baked samples on the box itself. So let's say you want to get into text classification, let's say you want to get into image classification, you want to get into analytics of time series, whatever, we actually package, or you want to get into specific languages like Julia, emerging language like Julia and stuff like that. We actually package very, very fully baked examples and samples in the form of Jupyter notebooks onto the VMs itself. So any person who's coming in newly into those particular environments can get really easily onboarded into those. What we're doing is that specifically for the deep learning VM, we're actually packaging a bunch of Microsoft developed or partner developed deep learning samples, like samples which, for example, compare different frameworks. So let's say you have a particular problem which is image classification for retail imagery, all right? Then you want to see which particular framework is the best for your environment. Let's say you take 5% of the sample data and you quickly want to swap out different frameworks. Like, does TensorFlow perform better? Is Cognitive Toolkit better at this particular problem? Or do I use another framework like Caffe or something like that, right? So we're packaging those specific deep learning samples as well if you get into the deep learning SKUs. And then finally, another announcement that we want to make, something we're very excited about, is the AI for Earth program. How many of you saw the keynote with the AI for Earth? Okay, 1 or 2 people. AI for Earth is a program that is being run by our chief environmental scientist and his org, and this is actually a partnership with Esri, where I don't want to go into a lot of details because this is a whole program by itself, but this is basically using deep learning to generate, imagery, which is, I don't know the specific term of that imagery, but basically, geospatial imagery from raw images taken by, either satellites or drones. So, we're partnering with Esri to provide specific research funding and actually work with the research community to build this out, and DSVM and ourselves were actually powering a lot of that project. But one of the good things that we're doing is that as a part of that, we're building a geospatial extension to the data science virtual machine, or which we're now calling the geospatial AI machine, or geospatial AI virtual machine, which you might have seen in Joseph's keynote as well. Actually, if you are interested in building extensions to the data science virtual machine, please come and talk to us, because there are a lot of organizations that are using this as the baseline platform and then building on top of it. So we do enable that, as there is a feature within Azure called VM extensions, which we're actively supporting even internally and also through different organizations.
We have some samples on our GitHub. I think one of the resources that we'll show is our GitHub, where you can contribute extensions. We have a couple of extensions that we work with a few partners.
Cool. So let me now go into the workflow. So this is specifically the workflow for data science VM that we have observed over time. All right. So typically, any organization has a bunch of shared data sources that exist both on-premise and in the cloud. So on the left, if you see your shared data sources, and on the right, you see your production systems. Where do we mostly see data science virtual machine being adopted? We're close to up to 20,000 organizations worldwide which are using this on a daily basis. So where do we see it adopted? So data science virtual machine kind of fits in the middle. It is kind of the catch-all for data scientists. So think of it that way, where you have your organization's data. The highest likelihood in today's world for your data's geographical location is possibly in the cloud, because the majority of your data nowadays is probably going to reside in the cloud. the idea with the data science virtual machine is to push the compute as close to the data as possible. At Microsoft, we've been working very, very hard to push the intelligence into the database wherever possible. Like if you've seen what's happening with SQL Server, included R and Python inside the database engine. But it is very unlikely that you will be working in an organization where all of your data just lives in one database. So most data scientists and data professionals are probably going to be working with multiple disparate data sources, and you will need to join them, marry them into a shared situation or I don't know, a massive machine somewhere to actually start doing something and training something and actually getting into a point where you could call, hey, this is an intelligent solution. All right? So for that particular scenario, may it be deep learning, may it be traditional machine learning, may it be simulations or HPC compute, that is specifically where we see the data science virtual machine coming into its own. So this is where we are, and this is not what we developed the product to be. Yes, we did, but this is the most relevant pattern that we're seeing the industry adopt, at least with data science virtual machine. Then, once you've actually built your models, whatever, you can publish them from the data science virtual machine to, could be Azure Machine Learning, could be a Spark cluster in Azure, could be any other source, any other production system. That's basically what the data science virtual machine is enabling. And finally, for those of you who are new to the data science virtual machine world, the key areas which DSVM is helping our customers today, and we want you to look at, is primarily the first biggest workload pattern, just like how I said, is analytics desktop in the cloud. If a bulk of your data, the data of your organization exists in the cloud, why don't we push the analytics design and compute to as close to the data as possible, right? Because we don't want basically people doing data science on their small laptops, all right? So we're trying to address that particular situation. Secondly, we have seen that an emerging pattern after we launched Data Science VM is that it is because of the ease of consistent configurations, it's being adopted by educational organizations and teams within companies to train their data workforce very, very quickly, because you can spin up X number of machines with the same exact configuration with 95% of the tools that most data scientists need in the most possible and probably most tested and vetted configuration that at least Microsoft data scientists have tested, right? After that, I've already spoken about the ability to use GPU compute, but the point is we can either spin up, the same image can spin up with CPU compute or GPU compute or any new hardware piece that Azure throws at you. And then we also obviously include a lot of examples and templates for you to get started. And finally, the batch AI training service and the deep learning workloads that we're enabling are some of the areas that we want you to investigate. All right. So, and specifically with I do think that specifically in the case of deep learning, it is important for us to actually recognize what GPUs are enabling in terms of training. How many of you are aware of the typical speed up in case of training when it comes to deep learning on GPU versus CPU? Some of you? Very few of you. Wow. Okay. So let me quickly just show you a video, which is, how many of you are aware of the MNIST data set? Okay, a few of you. MNIST is a very simple data set, which is basically 60-odd thousand images of people's handwriting, writing digits. And what the learning model does is tries to predict what that digit is from that particular image. So if I was to train a learning model on a GPU versus a CPU, I'll show you a quick video of what it looks like and what the speed up is. This is why GPUs are important. So on the left, you see a CPU cluster training it, and on the right, you see a equivalent size GPU machine training it. You'll see quickly that there's about 830 samples being trained on in the CPU, equivalent 12,000 samples being trained on in the GPU. So that's effectively, the kind of the difference that you'll see. You'll see a 10x, 20x increase in terms of GPUs. Basically, that's why deep learning is an area where GPU sort of workload is growing very, very quickly. With that, let me quickly now switch a machine and actually show you how you might go and use and explore the data science VMs and the deep learning virtual machines. Mind you, for this particular session, I've tried not to go too much into the depths of data science because I thought it'll be best to actually probably just give you enough idea. We have a very detailed lab as well as a hands-on lab, which we'll talk about later, that if you guys are interested, you can come and actually have a tryout on the machines as well. So how to get to data science virtual machines? So if you go to azure.com today, and let's say if you go to azure.com and you go to products, AI and cognitive services, and you go to the machine learning tab, you'll actually see the newly launched machine learning services, the already available machine learning studio, and finally the data science virtual machine. You can go here and actually look at what we offer, the work, basically what I've just covered. Here, actually, it covers the editions that we have available, and it also lists the 2 editions that I didn't list in my slides, and what's included. So if you go into what's included and you click on this, it will actually take you to our fully curated documentation page with all the tools. And one of the things that we've tried to do in our documentation is to make sure that in terms of discovering a lot of these things, it's a bit like this. There's a famous quote from the Excel team at Microsoft, and I'm sure you guys will agree to this. Everybody in the world, there's about 1 billion people use Excel, 400 million people use Excel. Everybody who uses Excel uses about 10% of the features of Excel. But it is a different 10% for every one of those 400 million people. So that's the pattern we see in data science as well. It is a bit of an art, so everybody uses a different tool for a different thing, because there is a lot of innovation going on in the open source space as well. And as you might have seen already, a lot of it is open source, even though it is a Microsoft product. So we've tried to make sure that we cover, in our documentation, we cover exactly what the tool is, how do you use it, where do you find it, how do you run it, and stuff like that. Let me quickly show you what a Windows virtual machine versus, I know, this part is like super boring, okay, because it is a virtual machine, so don't expect a lot of cool stuff to happen right now, right? Is that okay with you guys? Okay, cool. All right, so basically, it is as simple as it sounds. So this is a Windows virtual machine. I have a few things up and running. So data science virtual machine for Windows. We have a lot of a lot of the tools that you can go and have a look at over here. But here's also the Linux virtual machine for data science. So we will go into a few demos after this. I just wanted to show you that, hey, there's no crazy magic happening. This is a pure virtual machine, but the idea is to provide the least friction environment for a data scientist to not just use a small laptop, but use an actual, enterprise grade, fully security compliant, resource within your Azure subscription to do their data science properly. All right, cool. So I'm gonna hand off to Gopi, who's gonna take over and actually go into a bit of a deep dive.
Okay. Thanks, Barnum. Before we go into, so we're going to.
Can you guys hear?
Can you hear me?
Yep.
Hello. Check.
So what Gopi is going to talk about, let me just prime it for him while the battery's being recharged from the cloud. All right. So, yeah, the Azure electricity services. It's a virtual battery at this point. Sure. So it is a virtual machine at this point. It is not a managed instance like SQL Server. We do have plans. We haven't sort of crystallized those plans at this point, but at this point in time, because it is a virtual machine, a lot of the management does fall on you. The pattern we do recommend, though, is actually to persist all of the intelligence. The code needs to persist. Obviously, you have to have a good, that's basically what Gopi is going to talk about. Have to have a good source control strategy for the code. For the data and the intelligence and the models, have to have a good deployment and basically a CI/CD strategy. And for the VM itself, treat it as a temporal resource and just use the newest image, but remount a shared storage that you're persisting over time. But Gopi is going to talk about it in bit detail, and we can discuss this after the session as well.
Thanks, Banam. Okay, finally we are back online. So let's go into like what does a typical AI development lifecycle look like, right? Okay, so now we have looked at all the tools. We have looked at kind of a general architecture where you have the storage, you have the data science VM, and then we have like different targets where you can deploy these models that you are building and artifacts that you're producing. It could be a dashboard, could be a model, anything. So what we have done is, so we have defined this thing called the team data science process, where you can kind of define our best practices that our own data scientists follow, and then like industry standard best practices. So this is kind of like think of this like an outer loop. Okay, you start with some business understanding, you understand the data, and then you go through some modeling exercises, and then kind of go through a deployment when you have a viable model. And this is a very highly iterative process, inherently a very discovery-oriented process. So there's a lot of experimentation involved. And you might have heard that, okay, yeah, I think increasing the rate of experimentation is really the key to success in AI and data science. So this process kind of helps you kind of do that. If you kind of dig down, and there's more details on the team data science process itself, I won't go into a lot of details. There is a separate session that you can definitely take a look, or if you already attended that. So the inner loop is kind of an iterative development with the data science VM. So here you typically start, like when you're given a big data problem, you don't automatically start building it for kind of all the several terabytes of data. So you start like really small, so on your kind of a local, like a single machine, like a single VM. So it allows you to rapidly debug. And so this is where kind of using like a local Spark instance would actually help you kind of debug things faster than kind of debugging it on like a cluster, for example. And also you have all the tools kind of built in, so the data science VM comes with all these tools, so you don't have to spend time in kind of installing or ensuring that there is compatibility and all that stuff. So most of the most popular ones we already included. So this is a way you rapidly increase the pace of your experimentation using the local environment and the local all the debug environment and everything. So at some point, okay, you'll also get a pretty good idea, like how long will your, let's say you have to train your model on, let's say several terabytes, but let's say you take a sample of that and then you start training. So you get a pretty good idea, like when you go to the full data set, how long it's going to take. So at this point, you have two choices. Either you can scale up or scale out. And just from an architectural simplicity, if you can get away by scaling up, you would probably go for scale up. And but I think many problems may not. I think you may not be able to scale up. So by scale up, what I mean is like you just beef up your like your data science virtual machine into a larger configuration. Or can GPUs help? So can I run this instead of running on a CPU-based virtual machine? Can I run it on a GPU? So that is kind of the scale up. And if you are able to do it on like one single machine, that's I think that's probably the simplest thing that that you can do. But in reality, many real life situations you will require like way more than like one machine. And so this is where again data science virtual machine can work with like a remote Spark node. So you can build everything locally and then just point like the Jupyter notebook to a like just change the location where you're targeting it, and you can now target into a HD Insight cluster. Or you can even run like multiple nodes, like it could be a batch-based workload. So in which case you can submit it to like a batch training and run it on like multiple parallel nodes. If you're able to completely parallelize it or embarrassingly parallelize your workload, you can run it on like multiple node and take advantage of some of the tools like CNTK and TensorFlow. They do have the ability to kind of run it on like multiple nodes using like MPI. And then we also leverage a lot of We also leverage a lot of Azure features like Azure VM scale sets, which again allows you to kind of create a bunch of VMs, and that can actually and then scale up and down, kind of do all the auto scaling based on loads. So like you can set a threshold like, okay, my CPU is like less than 60%, I can actually start turning down nodes. When CPU utilization goes above 80%, I want to kind of bring up new nodes. So you can do things like that. So the good thing is, since data science VM is working at an infrastructure level, we automatically take benefit of like all the innovations that are coming in the Azure infrastructure space, whether it is security or scaling or geographic expansion. So we get all these things for free by kind of residing at the infrastructure layer. So let's look at the specific problem we are going to kind of take this end-to-end process. So here the problem is to extract entities. So we have a corpus of medical documents. So these are journal articles that in the medical industry. So our problem is to extract like what does each of the journal entries kind of talk about. So the data set that we use is based on the Medline corpus. So this contains almost like 27 million scholarly publications with like title, author, the abstracts, and then so this is these files are available from the PubMed, which publishes these this particular corpus, and it has like almost 800 XML files, and it's all like textual data. So I want to be able to make sense out of textual data. So this is a pretty reasonable size problem, and it's something that I think deep learning can really help in these type of situations. So briefly, okay, no, it's still this. Okay. Briefly, the architecture for this is, okay, so you start with the 27 million abstracts, and then go through an XML parser, and then convert them into like TSV files, because TSV is easier to work with when you are doing like Python or R. And then you kind of do the word embedding using the word-to-vec model. And then uses this embedding will become like the first layer in your like deep learning model, and then you train a LSTM deep learning model, and then you are able to deploy it onto within Azure. So this is kind of the overall architecture, and then we use Azure Blob Storage and then HD Insight. So we are kind of using various pieces here, leveraging, and then using the data science VM as kind of the development workstation here. And by the way, this sample is available as part of the new Azure machine learning services. So we'll just go through that. Okay, so here I am in the Azure machine learning workbench, and then so.
By the way,
can you really both?
Yeah, by the way, Gopi is actually right now logged into a Windows data science virtual machine, where we do provide, as of yesterday, we do provide the one-click or workbench installer as well. So you can go and try out. It's a very easy way to get onboarded into, if you don't want to just try to use your own machine, if you want to get onboarded into Azure Machine Learning.
So here I opened up the project within Visual Studio Code. And here, I think just like I think you saw the different stages in the team data science process. So we have like the different, so this is the one, this is a piece of code that actually downloads the XML file and then process it in Spark. So there is a local Spark instance. So we are going to actually download files. Obviously, we're not going to download 800 files here. So I'm just going to download one file. I can set those parameters. So what I'll do is I will run this particular program and then go into, go a little bit into the code. Okay, all right. Yeah, sure. Yeah, we can do that. So this is. From the actual, so we are downloading it from the actual PubMed site, so through FTP. So. Right, that's the full architecture, but I think when you're developing it, you remember the inner loop. The first loop is I want to kind of perfect my code first on my data science virtual machine. Now I'm ready to kind of have debugged it completely with a few files, and now I'm ready to kind of turn it loose on the whole data set. So I think the workflow will be kind of similar, but I think we start off with, like, start small with like a few files, do the parsing, ensure that, okay, we can parse the file, find all the like missing data and all that kind of stuff. You can do the exploration and try to understand most of the issues that you would expect when you get the work on the full data. Okay, let me go through that. Is this the one, number 7?
No, it's
number 5. Okay, so here, so we see this, the files are coming from Medline. And then, so instead of the HD Insight on the data science virtual machine, we are actually using it as a standalone Spark cluster first. So we use the Spark and then download the file, do the XML parsing, convert into TSV. And then once I think we are satisfied that this code is good, then we actually kind of run that same code on the HD Insight, where it will download like all the 800 files and the 22 gigabytes of file and put them into the blob actually. This is using plain Python actually. At this point it's using plain Python, and Azure Machine Learning we are using it to kind of track the runs and then do the experimentation, and then it offers like Spark libraries. In this case it's just using the standard ML library, but you can be using ML Spark that comes as part of Azure Machine Learning. Okay. So here, this is a plain Python program, so I can just run this is it clear? Maybe a little small. So it's started up a Spark cluster or a local Spark, and then it already downloaded the file. The download itself doesn't take a long time, but the processing, because it has to take XML and then it has to parse it. While it is doing that, let me kind of walk through it. It's a pretty plain Python code, so I won't go into kind of too much detail here, but I think, so here you are able to kind of do the parallelization. So that's one of the benefits that Spark offers, is parallelly I can, if there are 800 files, I can download like 800 files in parallel. Or you can set the level of parallelism that is there, and also how it is processing. You can actually set the batch size. So you're using, pretty much you're using, this is like pretty standard Spark stuff. So once it writes it, I can either write it to a blob. We have libraries that can directly write stuff into the blob. In this case, I think we are just writing it into local, into like temp Medline. So this is where we will be writing it. Okay. So now we see that all the records are processed. So I only process one file. So there are like about 15,000 records in that particular directory. So I think let me look at temp Medline 2. So this is where it has actually downloaded all the files, all the XML files, and then once it gets processed, they actually go into the PubMed, and then the TSP files are generated. So once this is done, so the next step is we are building a word-to-vec model here. So let me quickly go and build the word-to-vec model. So this is also done on the Spark, local Spark, and then it's actually taking the TSV file that we created in the first step, and then it's actually going through the word-to-vec model. So it's actually doing the training. So while it's going there, let me quickly kind of open up and show you what it looks like. But I think you can take a look at it at your leisure. We published all this stuff in GitHub. So this is taking that same file from Medline and then creating the the embedding model. So we use the skipgram, the word-to-vec skipgram algorithm that is available already in Spark ML. So we're just leveraging that same thing and able to kind of do that. So here you notice that this is already done. So it's already created the word-to-vec model. And now we are actually ready to actually take that word-to-vec model, use the GPUs, and then train that model, use an LSTM model. So this one, let me actually show you on the Azure machine learning. So say here, I think you have a choice. If you run Python, just Python, you won't get all the run tracking. I'm going to show you some run tracking with Azure machine learning here. So here, model creation, train neural network model. So this is the step 3 of this. So I'm going to do a run. So this, so while it's doing this, let me, oh, what happened? Okay. There is a limit of size. There is a big file that's sitting in the local directory. Maybe I ran one, so this is.
This is still public preview code, guys. So.
It is public preview, but I think I think I have a run. I think I tested it before.
I think one of the things, important things to note at this point is, at least in my experience, if you're, data science virtual machine inherently is a code-first environment, right? So, and you've seen, I'm guessing you guys are probably familiar with Azure Machine Learning Studio, the one that has existed, the GUI-based machine learning designing environment that we've had for just over, about 3 years now. So that's very much a visual, graphical design first, versus very much a code-first environment where, and we've tried to go as near PaaS, SaaS as possible, without taking away the art component of data science, which is a very, very powerful request from data scientists. Like, I am a code-first person, give me that code-first environment. So, but one of the things that that it's important to note with the new Azure Machine Learning Workbench services is the ability to actually track how your models are performing across runs, and comparing things like model, doing measures like model drift, things like accuracy tracking and stuff like that. Those are not necessarily things that have existed in a well-managed environment before. In data science inherently has been a very much an ad hoc field, not an engineered field. This is where sort of the investments from Microsoft are going as well in general. So that's sort of what the engineering part of data science is what we're trying to put some rigor around.
Yeah, so here you can see that we are tracking the run on Azure Machine Learning. I just had 2 big files, so once I moved those files out, I was able to run it. So right now you see that the training is just starting right now, and it's using, so this one uses Keras and TensorFlow as the model building, and then it's able to use a GPU here. Where is this GPU? Yeah, so Tesla, so GPU. And then you can actually see that it's actually using the, where is the, okay, so it's occupied, I don't see a lot of utilization, so there's something wrong here. So normally what you would see is, okay, so I can see that it's, this process is running on the GPU, and it's taking like almost a gig of data, and then it's actually crunching through these numbers here. So it's building the model, and so once the model is built, you will actually see that so it copies into an H5 file, and then now you are actually ready to kind of evaluate that model. And once that model is acceptable, you actually deploy it into production using the Azure Machine Learning operationalization.
So what operationalization actually allows you to do specifically is to take that particular trained model, which is effectively a serialized model, to package it into a container and publish it into a container cluster like Azure Container Services through the model, and you're using Kubernetes, et cetera, to actually manage that container farm, or take that, put that into a production data science VM or into a Spark cluster, depending on whatever your production environment is that needs to use it.
Yeah, this is kind of the core that actually does the extracting of the kind of building the LSTM model. And the LSTM model itself, you can actually see it.
By the way, just a question, how many of you are familiar with what an LSTM model is? Okay, very few people. LSTM is basically a paradigm within deep neural networks, which is called long short-term memory models. I encourage you to go and actually read about it a little bit. It's basically using, think of it this way, it's kind of trying to mimic memory in human minds to try and make predictions, all right? So I don't want to go into details of it, but it is something that's useful in a few certain scenarios, so long short-term memory models.
Yeah, especially for like language understanding, you need to kind of look at like words. So like, for example, you want to predict like what are the words that are going to be near, like if you say machine, the possibility of machine learning is kind of pretty high, right? I think, so it actually, so that's one way you need to kind of keep track of the memory. So the long short-term model actually allows you to kind of do that. So here we are building the actual, the embedding that we did from the word2vec. And then next, I think we actually add a LSTM layer here, and then a dropout layer, and then finally, I think there is a dense layer, and then that kind of finishes up your deep learning model here. Let's go and look at whether our run is completed. Okay, so here it is done, and so you can actually look at the run history. And I look at this.
So typically, in a typical data science scenario today, most people who are very code-first people will probably do these runs and try to track them manually as to, hey, is my accuracy 80% versus 81%? You know, across the. Sometimes you got to be very careful when you're training on new data. Sometimes new data may be actually impacting and decreasing your accuracy. You never know. There might be multiple different situations that may arise. So tracking, what your model drift looks like. Also sometimes tracking things like, hey, is a particular type of machine learning model better than the other? You know, comparing those two, champion versus challenger and stuff like that. There's quite a few different things that this new workbench actually allows you to do.
So now that we have the model, I think the last step is really operationalization. So here, I'm just going to run a command. So operationalization is also, so here, this command, essentially what it does is it packages up the whole model into a container, and then it can deploy it into Azure Container Service, ACS. So that's where you can actually serve the models from any of your clients can actually make like REST-based calls and then get the predictions. So this kind of completes the whole kind of the full end-to-end life cycle. I won't show the full kind of actual deploying model because building the container takes a little while, but I think it's a single command that actually allows you to kind of deploy it. So it's almost a one command operation. So this kind of completes like one deep dive of like one of the use cases. Next, I'll turn it back to Barnum for finishing up with one more use case of image recognition.
Okay, so now I think I'll keep this deep dive as much architectural as possible. Sorry, yeah, sure.
Nobody.
Into container service, yeah. Into web services, yeah. Yeah, you can. Yeah. So if you're using Azure Machine Learning Workbench, the new service that was announced, or using the new Azure Machine Learning, the new version of its command line interface, you can publish into container services. Your model, your trained model can be containers in Azure Container Services. If you're using the already existing Azure Machine Learning Studio, which you have been publishing into web services or with the API key and stuff like that you're probably used to already, that you can still do from the Data Science VM because we package the existing Azure ML SDKs are part of the Data Science Virtual Machine. Actually, one of the lab that I'm going to talk about, that's actually a hands-on lab, we actually publish an R model that is written completely code first, not using the GUI-driven interface, but publish it into Azure Machine Learning Web Service. as well, the existing version, using the Azure ML publish commands. Okay, so both of them are possible, and both of them are possible from the data science VM.
Yeah, this is part of the Azure Model Management Service. So this command line that I showed you. So that is so Workbench is a data wrangling and experiment management tool, and then the command line allows you to kind of do the operationalization. So.
Cool. So in this particular example that I just quickly wanted to speak to you about, I probably won't go into too much into the code. I'll just talk to you about the architecture, and I'll show you the end outcome. And then towards the, we'll probably end the session and then go into questions if you want. All right. So in this particular one, this is actually a very cool example that some of our colleagues did. This is actually using images, retail images, to classify products in photos, all right? So it's using convolutional neural nets. So effectively, what the process actually looks like for this, and as you can see in the training data set for here, it's only 60 photos, so it's not a lot, not a huge training data set, but they're getting like really good outcomes, really good results, because it was a very well scoped out problem for retail products only. So it is something that's worth noting. So the images kind of look like that. Those are the training images. I'll show you them in detail if you want. That are being for training and scoring. There's and there's some metadata about the images, and what the labels are in terms of training images. This looks like a tomato versus that looks like some ketchup or something like that. All right, and then what we do is we actually, in our case, these are actually the image blob files are actually hosted in Azure Blob Storage, because those are basically just blobs. And the metadata about the images are used in Azure Cosmos, are stored in Azure Cosmos DB via the Document DB API. How many of you have used or are aware of Cosmos DB? Okay, some of you. So Cosmos DB is a multi-model NoSQL database store in Azure. It's a PaaS service that is actually now quite famous for its latency SLA. So it's a very low latency, multi-model NoSQL data store that is geo-distributed, and you can replicate real time. All right, so if you haven't learned about it, I suggest you should probably check it out. It's a cool service. I personally like the service a lot. So in our case, we actually do that. And then the flow after that is, hey, the blobs that are the images exist in standard blob storage in Azure. The data about the images exist inside Cosmos DB. And then we have the data science virtual machine. In this case, I'm just using a Windows one. It doesn't matter which one you use, where these two are actually brought in. And then we score, basically train a model using the Microsoft Cognitive Toolkit. How many of you are aware of the Microsoft Cognitive Toolkit? Show of hands. Probably 10, 15 people. So Microsoft Cognitive Toolkit is a set of basically a deep learning tool set that's published by Microsoft. And it is basically a lot of deep learning algorithms that are developed and maintained by researchers in Microsoft Research, and also parts of our team and multiple different teams within Microsoft. So are you familiar with TensorFlow? Some of you? Not a lot of you, okay. So it's TensorFlow, MXNet, Microsoft Cognitive Toolkit. These are probably the major sort of, and then Caffe2 from Facebook, etc. Probably the more major deep learning frameworks that are available. And in this particular scenario, we use Cognitive Toolkit to actually go and train the model. And in this particular case, that model is actually then using Python Flask. It's actually published to a web service. This is, in this particular case, it's not using cognitive services. This is using standard Azure Web Services. This is actually a full walkthrough of this solution how-to guide that you can go and run. Is actually available in GitHub. But basically, you deploy using source control to a web service. All right. I don't have enough time to go through the full details, but if you're interested after the session, I can show you the exact code and whatever. And basically, it's a web service is basically running some version of Python. You just push source to it, and it just does it that way. All right. What do we get out of it? Actually, Before that, I go into a little bit of the detailed architecture of this. As you can see, this is kind of what I was talking to you about. This is a detailed architecture diagram. We have the data sources being annotated and then put into DocumentDB and storage, data science virtual machine being used to actually go and actually train the models, and then that trained models are being published into a test website. Power BI, in this particular case, how many of you are aware of Power BI and have used it? Okay, quite a few of you. Power BI is a very popular product. I like it myself a lot. So in this particular case, I'll show you very shortly, Power BI is actually used to look at the model accuracy, over time, if you are doing multiple versions of a model, how has my accuracy changed and stuff like that. Kind of inherent things that the new Azure Machine Learning Workbench also provides. But if you are doing it as a code-first approach and you're not using the Workbench, and you're somebody who has ingrained data scientists who are like very much into R and Python code, and they don't want to touch any GUI-based system, great, no problem. We do provide solutions for them, and there are a lot of people who are like that as well. So that's kind of why we focus on those. And sort of to walk you through how the neural network workflow actually works, we have the input images where you do a lot of extraction of regions, and then those regions are extracted, and then there is some labels in the training data to say, hey, this particular area in the image kind of looks like, I don't know, a person, or in this particular case, X product, Y product, and then it identifies it that way. So it uses convolutional layers. How many of you are familiar with convolutional neural networks? Okay, some of you. These are extremely popular when you're dealing with image processing and video processing, etc. One of the tools we actually provide in the data science virtual machine is the VOTT, the video and image tagging tool as well. So basically, you can take any image or video, start selecting areas in that video or image, and say, hey, that's a horse, or that's a cat, or whatever. So this is a pretty common use case when you're trying to build your own training data, or you can always obviously purchase your training data, or you might already have data that's already labeled, because a lot of the times when you're trying to train models to actually deliver predictions, you need to have good training data, right? So let me actually go into the lab a little bit.
Number 8.
All right. So in my case, again, I don't want to go too much into the code, etc. But effectively, if I wanted to show you the code, it's a lot of runs, basically. I don't want to show you that. What I want to show you is this. So this is the actual solution how-to guide that has been published by the team. And let me actually go into this area. So it uses images sort of like that. And if I go into the actual virtual machine over here, actually go into the image. This is the training data set of images, all right? So there's a lot of like sort of training data. This is Windows Server, so it's opening it in Paint, but that's basically what it is. This data actually goes in to your blobs that we're putting it in. We have a Python script that puts it in to the blobs. This is the metadata about the images, where it contains, hey, what does this image have? What are the areas that I care about? What are those areas? Is that a tomato? Is that a particular juice or whatever? And then puts that inside your Cosmos DB. And then we go and run a bunch of I don't want to, again, go into too much detail of the scripts, but basically it's using CNTK, convolutional layers, to actually go and train with that imagery and that metadata, all right? And then we build that, that model itself, and then publish it through Git into a Azure Web Service. So what does the web service actually look like? So if I go to, this is one of the services that we published. This is a resource group. This whole particular example has been published into one resource group. As you can see, all of the resources are actually published there. This is the data science virtual machine that I'm using. This is the Cosmos DB that I'm using. And then, okay, it's not sure what happened. But anyway, And then this is the actual web service. So let me actually quickly show you what the web service actually looks like.
So this is just an alternate way to kind of operationalize. So instead of using container servers, this is using Flask. Python has a framework called Flask that allows you to host like Python modules that you can call from a client.
I think that little glitch kind of messed up my system a little bit. Sorry about that.
Directly the website.
No, I think it messed up my internet connection. Okay, it's back. Okay.
Yeah, we've got 9 minutes more. So while Barnum is pulling it up, are there any questions that we can? Yeah.
Sure.
GPUs in the machine and to use those versus just spinning around and using the CPU?
So the VM itself is kind of an instance that's actually really like you own that VM, right? It's your instance. So you have like full control over that VM and like what configuration that you provision. So so what we provide is like the virtual machine image. You can deploy it in your subscription into either a GPU instance or a high CPU instance or a high memory instance. Depending on your workload, you can deploy to any of these VM types. So that way, like you control like where it actually gets deployed.
But is it a configuration that you have to
Yeah.
do in your code somewhere that says,
Yeah.
hey, I'm now running?
The image itself is you can deploy it on either a GPU-based machine or a CPU-only machine.
No, but it is important that you actually set the compute context to where you want to execute. Like some frameworks will probably pick it up automatically if you have GPUs by default. But like for example, the sample I have, it's the MNIST sample that I was talking to you about, where it's training on the data, the digits that people have written and trying to score. Like there is a point where you actually set compute context, like either GPU or CPU and stuff like that. So it is. I mean, if it's a machine, if you're using epochs and etc., or then you probably have to use GPUs. Because you're starting to get into areas where a CPU will probably struggle a lot. So especially in like image heavy sort of situations, but yeah, you have to set the compute context. Very quickly, I did want to just quickly show a few things. I was talking to you about the web service. So this is the web service that's being published. If you actually go into the web service itself, you can actually see that the deployment, there is actually some continuous delivery stuff that you can actually go and apply. There's deployment options in this particular web service. We've set up Git, so I was just pushing it from Git itself. But you can also check out that in this particular web service, if I was to go into extensions, what's actually happening is that this particular web service, when I first provisioned it, I provisioned it with Python 3.5.3, x64, and that's what I was developing my code on. So when I built a cognitive toolkit model and I was happy with what sort of work it was doing, and I wanted to publish the web service with the front end, the web role and the worker role with the front end, and then provide the scoring loop where you provide new images and stuff like that. All I had to do was do a git push to my code, because it's a consistent version of Python across my version versus the web service itself, and it ran, so like I was able to just push new code. What does the final website sort of look like? It looks like this. So basically, if I was to go and open up the work, this is a scored image already, but if I was to go here, let me go back. So this is just to put it this way, the kind of web service, this is like you can choose whatever you want. Let's say I want to use that particular image, use this photo. All it does is actually in the background, the trained model that I had built is using that particular model to actually go and look at particular regions within the photo and actually score them, like, hey, that's an orange, and what is the sort of confidence level with that particular prediction. And then the Power BI, there is a Power BI file that actually ships with this as well, but what you can do is, you can actually point that to your own Cosmos DB instance and actually go and look at your accuracy, your precision recall. I only have one version of this model here, but if I was to go and do another git push, or for example, and have a new version of that model, I can give it a version number and it will just show up here and actually have more versions. Then I can do comparison across how are my versions performing, et cetera, et cetera. And then I can actually go and look at, how good is it in predicting avocados versus predicting mustard, So apparently it's really good at predicting mustard versus avocado. I don't know why, but again, that's where a whole new concept of deep learning explainability comes in, all right? So, but that's effectively it. I want to quickly now go back to the slides and actually do a little bit of a wrap up and also talk to you about our hands-on lab as well. So if I can quickly show you that. This is, let me just quickly open this up and talk about the hands-on lab. So if you are around, and do you guys know where the immersion area is for hands-on labs? Yep, it is right kind of right behind. There's a massive area with a lot of workstations, surfaces, whatever. Let me change to this. Feel free to take a photo of this. We actually have a full-on hands-on lab going on with a full manual. We typically run this as an instructor-led lab session as well, but for this conference, we're running it as a full DIY lab, but both Gopi and I will hang around there, so if you want to run this with us, it's probably about 45 minutes worth of your time to actually run through 2 specific scenarios with code very deeply. So we have one of the examples where we use Jupyter notebooks, or how many of you are familiar with Jupyter notebooks? Yeah, quite a few of you. So we use a Jupyter notebook to collect some Twitter data using Azure Logic Apps. We've collected that for you, which is stored inside SQL Server. And then we use scalar functions in Microsoft R Server within SQL Server to go and do scale out word analytics on top of it and generate a word cloud and a word frequency matrix out of it. Very simple example, but how can you do it scale out? The second part, we actually use a graphical analysis tool that is built by one of our colleagues in the open source community called Rattle. It's a R-based tool that is used for graphical analytics, and graphical wrangling of data that generates, in the background, it actually generates R code for all the graphical stuff you're doing. And then you can push that R code into wherever you want to by using either Azure ML functions or whatever you want to, where you want to host it and stuff like that. So we have one of those examples as well. I have a full manual that I wrote after not sleeping for many days. So I hope you guys come into the lab. So it's HOL 3034. I'll give you a quick example. And that's the photo that you see over there with the word cloud is what you will generate after analyzing about 200,000-300,000 tweets collected with regards to big data trends and stuff like that.
Yeah, another thing is the hands-on lab, so you get access to like a full data science virtual machine. So in addition to these things, you can just kind of look around, play around. There are a lot of Jupyter notebook examples that are already available, so you can take a look. Yeah, it's not a GPU, but I think you can still do a lot of machine learning stuff on that.
Yeah, so let me quickly show you that example, what it looks like, and hopefully you guys can actually come and try it out with us. Sorry. So this is the Jupyter notebook that I was talking to you about. This is where I've actually built a GIF of what the Logic app actually looks like. And you'll actually, Jupyter notebooks is a very self-explanatory. I actually go into the code and all the different queries, how to work with SQL Server, how do you have your SQL Server databases configured, and this is sort of the word frequency matrix that you finally develop, and this is how you do it. It's fairly simple and straightforward, but it actually touches a lot of the included points within Data Science Virtual Machine, which is why I've sort of had it on there. And important to note, there's a lot of samples in the in data science VM. So if I go to the home directory, this is just Windows. In Linux, we have a few more because of the availability of a few more deep learning frameworks. And you can go and try out. Like I said before, we have 45 odd highly tested, fully end-to-end samples with code running that you can try out from the get-go. Now we're about to close very soon. I have 1 second. Let me quickly go to the screencast and just show you. Yes, please come to our hands-on lab. We will be there today and tomorrow. I'll probably be there Thursday as well. Actually, after the session, come to me if you want to do the hands-on lab with me. I'll sit down with you for sure, no problem. Also, we have a free test drive as well. So you can get access to the data science virtual machine and go and try it out without having to go spend Azure dollars. Just go and try it out.
This is a Ubuntu data science VM. So
yeah, this is the Linux version. Yeah. And we also have a lot of resources. Feel free to take a photo of this. We hope you find it useful. We run a community forum as well, where we get a lot of questions from users of the data science virtual machine globally. We try to answer as many as we can, but the community answers them as well sometimes. We run quite a lot of that stuff as well. So, and hopefully that's helpful. Please take a photo of this. And we're open for Q&A at this point. Hopefully that was helpful. Cool. Okay.
I just want that subset of them, so I'm not spinning up, or I'm not using the storage resources that all those other tools would
okay.
really require. Is there the ability to have those?
Yeah, sure. So the short answer is yes, because like I said, we have done this before for other customers. We've helped them. I mean, a lot of people can do this themselves, but it's basically as simple as having a desired state configuration for your machine. So if you know, it's very easy for us. The IP that we protect is how we generate the build, right? Once we've generated the build, what you do to it, you can obviously have your, PowerShell script that, we've had requests for people who want to use only, older versions of tools. They don't want to use this latest and greatest X, Y, Z. And we packaged a newer version. So one of the scripts is, hey, can you get rid of this and do that? A good example is the geospatial AI virtual machine that we're doing. That is a template that basically Esri has built in conjunction with us, which installs their stuff. Our Anaconda environment needs to be configured in a certain way, et cetera, et cetera. So yeah.
And that was actually my second question. So for the geospatial data science virtual machine, do you need to bring your own ArcGIS license as well?
Yes, at this point, yes. Okay. At this point, yes. There is talks about it. We don't know. It's not very clear as to where we go with other sort of methods of purchase, but there are plans. But at this point, it is bring your own license. Yes, correct.
Is that the case for the rest of your software?
Okay, important point. The data science virtual machine is baseline compute charges only at this point. There is no premium software charge on the data science virtual machine. It is the same charge as spinning up a vanilla Windows or Linux box on Azure. It is a fully convenience package. We only include either free to use or dev editions only. We are not including any premium licenses at this point. This is something that we have had requests for, like people want to not use SQL Server Dev Edition, they want to have SQL Premium on there. People have asked, hey, I want Visual Studio Enterprise as opposed, and those are considerations that we're doing right now, but at this point of time, it is completely a convenience package.
Will Docker images be available?
Will Docker images?
Docker is already there on the 2016 and Ubuntu.
No, you're talking data science VM as a Docker image?
Yes, a Docker image of this.
Oh, okay. Docker image of this is not in plan as of now, but you can run Docker containers on the data science virtual machine.
I can put together a Docker image with all that software myself, but you have more time than I do.
Yeah, I mean,
and again, I think here's what I think little bit, I think the struggle, I think in Docker, I think you try to create like a lot of self-contained applications. So there's already like Docker containers for Jupyter, Docker containers for all these things. So you can technically build your own Docker container with a bunch of Docker images that are there. But kind of creating one with like all these dependencies, it actually gets a little bit more complicated. So,
Yeah.
so we haven't completely ruled it out, but at this point, at least it's not our priority.
Quick question. Good presentation.
Thank you.
For the presentation slides, are you on LinkedIn? Can you, if one sends you an invitation?
It should be there on My Ignite, but if it is not there, please do.
Yeah, we're both on LinkedIn.
On LinkedIn, okay.
If you should have the slides downloadable from My Ignite.
Yeah, I checked for the slides from yesterday. They weren't there, so.
Okay, it'll probably be after the conference because I know that they do a check before publishing them, because just to make sure that there's no non-disclosure content. So, but it should. But feel free to just reach out to myself or Gopi on LinkedIn, and we're both available. Also, any of you interested in doing the lab, let me know. We'll be there. We'll help you out.
Is the lab available after the end of Ignite?
It will be. I mean, as long as you have access to My Ignite, which access doesn't go away, you're signed in. It's just, it should be available for a year, I think. Obviously, our solution will change in a year, but yeah, the lab should be available for a year. That's what I've heard.
Yeah, you can do it on your own laptop also.
Yeah, so if you want, you can just take the lab manual and just do it in your own Azure account. You don't have to use the lab itself because it's the same image that you can use in the lab versus going to your own Azure account and spinning up the data science VM. Cool.
All right.
They
Okay,
are?
cool. Thank you.
Oh, cool.
Cool. Thanks.
The slides are posted.
Yep. You just sent it to Seller Fox just before. All right. Thank
All
you
right,
very much.
thank you very much for staying, and thanks. Hopefully that was valuable. Cheers.